All right, so here we're going to look at matrices and systems of equations. So like I said, matrices basically are going to serve as a shorthand for solving systems of linear equations. And so let's say we have this system of equations. What we're going to do is we're going to convert that into a matrix. Now there are three different types of matrices we can use with this. We can have just the coefficient matrix, the 3, the -4, the 2, the 5. We can have the constant matrix, which is the right side, what it's equal to, 7, -2. And we can have augmented matrix, which is both of them combined. So basically we're taking this and this one, shoving them together and putting a straight line between the two sides. So this would be 3x, and then there's supposed to be a minus. I don't know where the minus went here. Minus 4y, and then 7, and then 2x, and a 5y, and a -2. Okay, so that's going to be how that works. Now, generalized augmented matrix for a system of two linear equations and two variables basically is going to look something like this. So we have, x1 and x2 are going to be our two variables. A11, A12, A21, A22, and then K1, K2. And so this is kind of what the augmented matrix is going to look like. So that's going to be how we do that. And so this is going to be, two rows, two columns, and then we'll have our third column is the augmented part, which is going to be our constants, the K1 and K2. So theorem one operations that produce row equivalent matrices. So what we're going to do is we're going to try to start with something that looks like this, and we're going to try to reduce it to something that looks like we have a 1, a 0, a 0, and a 1, and then whatever K1 and K2 end up being at the very end. So we're going to try to start with some numbers over here, work our way down until we get something like this. And so the operations we can do is we can interchange two rows. So we switch row I with row J. That's one option. A row is multiplied by a non-zero constant, so we can take 2 times row I, and that becomes our new row I. And we can take a constant multiple of one row and add it to another row. So we can take k times row j plus row I, and that's going to be our new row I k. Now the arrow basically means replace, and this one is we're interchanging, basically going back and forth, so it interchanges it. So that's going to be some of the operations we can do on the matrices. And they keep them the same, it just changes what it looks like. All right, so let's stop there and let's come back with some exercises.